Good afternoon, my geography students or learners. Today we are looking at how we can identify and represent relief features by contours. And I'm still your tutor, Sir Amasanity, taking you through this topic today. Let's continue. By the end of the lesson, or after watching this short video, you as a learner should be able to explain the meaning of contour, lines, and identify its features, and also identify some major or popular relief features on Topo sheet by their contour. Sometimes in the graphic paper 3 question 1, which is compulsory, apart from you being either asked to find for a gradient or distance on of some linear objects on the map, or even being asked to do reduction and enlargement, or drawing what is called cross section or profile drawing, the learner can also be asked to identify some features on the topo sheet and mark them with some alphabet. So we are going to look at how you will be able to identify. You should be able to identify those features on the map, and that is what we are going to look at first. So when it's a contour, you're looking at the imaginary lines that join two places, but you can't see them with your eyes, having the same elevation above sea level. So the line that shows that this place and this place, these geographical areas have the same height, but we use the contour line to show it on the map. And the method that we use to show these features through contour is very useful and versatile. The contour lines on the map provide a useful insight into the topography of the area. So as we continue, what you must first know is that before they give you topo sheet, then that you are going to draw cross section or profile or identify, you should know the contour intervals on the map. You should know the vertical intervals that these contour lines are having on the map. And the first thing is sometimes maybe 50, 20, 100, 1,000, or whatever it is. You should know that from this contour line to the next successive contour line, what is the value between the two? That is what we term as the contour interval, the contour interval. That is what we call the contour interval. So you should be able to know the contour interval and know that. And it is usually constant on a given map. It is generally expressed in meters. So if we have 100, then maybe another one, there will be no value on it. But you see them say 300, you see 500. It should tell you that the difference between these contour values is what? Is 100 meters apart, or differences. You should know that. Then the use of contour lines has taken a comparative advantage and popularity as a method of representing relief on most of the maps we use. So normally topographical nature of a place or area is shown by the nature of the contour. So when you transfer it on a graph, when you are asked to draw cross section, how the topography of that area it's what you will see on the graph sheet if you really draw it well. You see that on the graph paper if you draw it well. So that is the contour. So different landform have their own different what contour nature. So you can't say that a hill or a mountain have the same contour values or features representation like a valley or a gorge, maybe like a cuesta or escarpment, whatever. All these reliefs have their own way of seeing them on the topo sheet that a candidate should be able to know and try to how do you call it? Know that this is this is that. You should be able to know that here is area reliable to flat. You should be able to identify them by using their symbols. You should be able to know that this place is a trick station where they use the value, the contour, the triangle with a dot inside the number beside. When you're able to see all this thing on the topo sheet, to tell you what that thing or that relief represent at a particular given time on the map. So this one, let me just move on because here is not necessarily needed. They are basic features of contour lines. It is not all that needed. So let's look at strips. Now when you say slope, you're looking at the degree to which a surface turns upward or downward. So whether the place is rising up or it is falling, whether it's increasing or decreasing, that is the slope. Now the spacing of contour line shows the nature of the slope. how the contour line on the topo sheet is either closed or opened tells you the kind of slope or nature of landform what is found at that particular area. So looking at the types of slopes, we have even or uniform slopes, you have gentle slope, steep slope, concave, and convex slope. And in exams, when you have let me say a ridge, they can ask you to indicate some part of the ridge or the highline, which is a steep slope or gentle slope. And please, my learners, my geography students, you should be able to know all these things. So when it's evening slope, that one, the altitude with distance from one point to the other is the same. If the slope is steep, it is steep throughout. And it is gentle, it is gentle throughout. So like if you look at the image I have around here, the contour I have around here, you could see that the space and the distance between all these contours that you see here is uniform, is equal, which tells you that the relief of that area is having a uniform or an even slope, having an even slope. Okay. So even or uniform slopes are shown by contour lines, spacings, or equally both in distance and number. So you can see that. You can see that. As I said here, you can see. You can see that. So that is what is called the evening slope. The even slope. The even slope. Now, gentle. When the degree or angle of slope of a nature or a feature is very slow, the slope is gentle. So when you look at the diagram that we have here, and look at this diagram, you could see example or gentle slope, but on the topo sheet, you will not see it like this. You will not see it like as you see here. But this nature of the contour will tell you that the place is having gentle or a deep slope. On the topo sheet, the contours representing this type of slope are far apart or widely spaced. They are widely what? Spaced. You can see, yes, the spacing between is not the same. It's not the same. Then you come to steep or gent or scarp slope. So when you look at the steep or scarp slope, that one you will see that the contour lines are too close on the topo sheet. Why it appear more brownish color? Because you already know that highlands or the lines are shown with brown colors or brown line. What is the contour lines are shown with brown lines on the topo sheet. So the point that you will see the contour lines appearing more, you're seeing the brown lines more on the paper. Touch that place is a highland area or is a little bit higher than the surrounding areas. So what you should know that the place that come too close, the place where the contour lines are too closer, that place represents the steep or the scarp slope. So this means that a slope is steep if the contours are closely arranged. So if the contours are closely arranged, it tells you that that place or that side of the highland is representing a scarp slope or a steep slope. Thank you. So when you look at this place, you will see here it's a slope, but it is not down to very steep. When you are asked to even climb here by using bicycle or even climb this place by yourself, you find it difficult to do so. You should decide. Because it is very steep in nature. That is it. You should know that. You should know that. So looking at this image that I have here, okay, this one, is gentle because you see when you are even asked to climb this one. A typical example is the staircase that they do for disabled people when they get to go to hospitals or go to some offices. They made that place gentle so that they can push their wheelchair and climb. But look at this place, this side, which is the steep slope. Look at this place. Look at the slope. It's very, 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 very steep. Like when you are climbing, let me say a staircase, but staircase is not having that terrace on it. It's very, very steep. So this example, when look at this diagram that we have here, when look at this diagram here, we have two diagrams here. We have two diagrams here. This side, mark A is gentle, while the place here mark B is very steep, all because the place mark B, the contour lines there are very close, too close than as compared to the one at this side, which make this place gentle and here become what? Steep. So when you transfer this contour line from on the graph paper, in case you are drawing cross section, the image that you have on the graph is what you see down here. It's what you see here. Sorry. Yes. What you see here. You could see that this side here is gentle, but here it's what? It's steep. Who tells you that? So you should know all these things. Know all these things. Know all these things. Concave slope is there. Then we have converse. I want to move on to other things. A valley. A valley. A valley. So we say that a valley is a low-lying area which is found between two highlands and is generally contain water courses. Normally, water passes through valleys. So when you look at the diagram that we have here, like at the extreme right corner here, you could see that. Now, a valley that contains a river is called a river valley, while the one without river or water is called a dry valley. So, on a topographical map, valleys are represented by either U-shape or V-shape contours. Then the contour curves inwards, and the numbers decreases inward. So, as you are counting in to the smaller contour within, the values reduces, but as it goes outwardly, the value increases. Tells you that it is a valley. And in the opposite of the valley contour representation is the spur. So as the spur, the contour, the value decreases inward. For the spur, the valley decreases rather hot inward. Tells you that the part of the land has been projected outwards. That is the spur. So there is an example of a valley. Now you may see on a map. On map, there's a valley. So this is a V-shaped valley, and here is U-shaped what? Valley. We are saying that the value decreases inward, or the inner contour has a smaller value, and the outer contour have the higher height. But so as it's progressing outwards, the value increases. That one is the valley. How you can see already from valley there. Now when you talk about spur, which is a tongue of land projecting from higher ground into the lower ground. That's the spur. Now, the difference between the spur and the valley is what I said, that the number for spur increases inwards, while the valley that's what decreases inwards. So that's the difference between a spur and a valley. So here is a spur. It's a spur. You see where the land here is projected outwards. There's a spur. It's a spur. Then you see there's a highland, and this place is a low-lying area. Some part of the land here has been projected or moved into the low-lying area. This small place that you see here, this small place, has been prolonged into the low-lying area, forming the spur there. So on the graph, you will see that this small place here has projected out, telling you that that place is a spur, and here is a ridge, making up of lowlands and highlands, synclines and anticlines. You could see those ones there. Yeah. So this is how it's also shown on the map. How it's also shown on the map. That is the spur. Now what you have V shape and the U shape spur. Okay. Conical hill. Conical hill. The thing appear like form of a circle. That feature appears like form of what? Concentric contours, like circular form. At least you will see two of the inner contour lines near circular in shape. And when you see that on any part of the map, it tells you that area is having a conical hill. You can be able to use CH to represent a conical hill on the map. CH. CH on the map, conical hill. So this is how it is. It's how it is. You see the slope, you see the landform we have here in the middle, you have the tree. It represents a conical hill there. Good. Now, a knoll is the smaller form of the conical hill. Yes. It's normally an isolated hill. It is found in open space, like it's not all that close or all that bigger like the conical hill. That one, the difference between it and the conical hill is that the knoll has a lower elevation. It's not all that tall. And what baby, it's not all that tall. The knoll is not all that tall as you may think of or you may see. Aha. So that is the knoll. And this is the diagram showing a knoll. You could see the contour line, then small something like this, 2 or 3 round, small round circles will be around. Let me go back. Huh. Let me go back. So this is how it is. You see about 2, 3 circular circles on the Topo sheet, telling that that place is a no. You can actually use symbol like KL to represent a no on the Topo sheet when you are asked to identify the features on the map. Yes. So that is it. That is it. Now a ridge. A ridge. A ridge is a narrow, long chain or range of highlands. You see that it's narrow chain. A ridge is long, narrow, and upland, usually with steep sides. So it's not all that broad, but it's narrow and it's very what? High. Now the contours representing ridge are not necessarily circular, but it is what? Elongated. It is elongated. This is what we mean when you say that is elongated. Like the thing is stretched out and it's not all that wide, but it is what? Narrow and very long. That is the ridge. So this is a ridge. Now the openings between the highlands or the ridge is called the gap. The gap or a pass or saddle or a cove. The same thing. Now when the pass is formed when the cove or the saddle is being used as a route or communication route. That is that. That is that. So it is also an image of a ridge. It's also an image of a ridge, as you could see. We have the highlands here. We have the highlands here. Now this place is the coal. Here is the coal. Here is the coal. Then this place that the footpath is, because it is used as a footpath or as a route, it's no more called a coal, but it is called what? A pass. A pass or a gap. So here is a coal, a saddle, but this place is a pass. It's a ridge. Good. Thank you very much for getting the concept of a coal and a pass. I've already explained this. I said that a coal becomes a pass when it is used as a route or a way. So that is it. That is it. That is it. So some of the images, you have escarpment. One side is steep, other side is what? Gentle. So here is scarp, that is steep slope. Here is the scarp. Okay. Okay, let me see. Let me see. Let me see. Okay. All right. This is a plateau having a tabletop surface. That is the plateau. You should know that. Now we have what's called the disserted plateau when it is crossed with, or river crosses through that plateau. If I was called that plateau, or even when river takes its source from there and it flows through the plateau, we call that plateau the plateau. So normally you see the inner part having no contour values. That is the plateau. That is the plateau. That's the plateau. This side. I'm talking about here. Talking about this side. Yes. All right. So, God of time. What I said. It's what I said. You should know what I said. Highland, where water bodies take their source from. This is what I said. You should know all these things and try to keep them a god. Uh, a narrow, steep-sided valley between two hills with rivers usually running through them. So that's a god. You have a cliff and others. So please try your possible best to make reference from your learning materials as you're preparing for your exams. Try your possible best to have all these things at uh, your mind so that you can record them and also try to do in case you meet composite question what demands you or want you to identify the features on the Topo sheet. You should be able to know. I think 2023 was exams for Ghana students. They had questions like that. So please try your possible best to make references from learning materials and know more about how you can identify these relief features. Thank you very much for watching.